Hello everyone, good morning. Welcome to Ganit. Today we are going to start with a new topic, midpoint and intercept theorem. As you can see, the name of the topic already being written. Midpoint and intercept theorem is one of those geometry topics. You can find it in grade 9th ICSE. I believe it's there in grade 9th CBSE as well. It's one of the topics where a lot of proving questions are there, and precisely that's the reason the topic is not liked by many. But it also depends on how you have studied the theorems, how you have, how much understanding you have of the midpoint theorem, when to use it, when not to use it, how to go about the converse of the midpoint theorem, what is intercept theorem, how many lines are involved in an intercept theorem. So small minute details which are right in front of you, but probably you have overlooked it, and maybe you have not paid enough attention to it. So without any further delay, let's begin with the midpoint theorem. I'll explain you the concepts first. In this class and in the next one, I'm going to explain you two parallel topics: midpoint and intercept theorem in one, circles in another. And then parallelly, these two playlists will be created so that you can see the videos as well as the practice questions, the concept videos as well as the practice questions. So let's begin with the midpoint theorem. Midpoint theorem, I will not explain it to you the way your textbook tells it, your school tells it. I will probably break it down with all the important parts, and then we'll combine the theorem in the end. Okay, so we will write down the ingredients first. Okay, so diagram, very important. What is the diagram of midpoint theorem? You probably would have seen in your textbook, they draw it like this. So A, B, C is our triangle, D and E are our midpoints. So the diagram is this. Now, is this the diagram exactly that you are going to get every time? No. Very rarely, in fact. You will get the same exact looking diagram very rarely. So, what kind of diagram are we searching for? Any diagram which has a triangle and two midpoints given to you. Now, that diagram could be a parallelogram and a side extended. Now, you might be thinking how to spot that diagram. If you see, if I mark this as triangle PQR, and for instance, just for instance, suppose that this is A and B, then you're looking at triangle PRQ. It plays the same role as triangle ABC here. So the diagram will not be solo. Any good question which is worth its marks, which is 3-4 marks question, they will not give you a straightforward midpoint theorem diagram. You have to search for it. You have to break a little bit of sweat for it. You have to find it in a quadrilateral. You have to find that triangle in a trapezium sometimes. You may have to find that triangle in a parallelogram. Many different instances are there. Okay. So the questions will not be as straightforward as the theorem looks. So be prepared to search for the triangle, the standard triangle in a complex diagram. Okay. That's number one. Number two, what will be given to you? How, when you read a question, how would you tell that it is a midpoint theorem question? How would you know that it is not a converse of midpoint theorem question, or it is not an intercept theorem question, or it's not a congruency or a similarity question? You read the question, how would you recognize that this is a midpoint theorem? And trust me, guys, this is very, very crucial. It is as important as the theorem itself. So you need to know while reading a question that I am actually looking for a midpoint theorem question. Otherwise, there is no point in knowing the theorem when you cannot spot it in a question, right? So what will be your given information? First and foremost, two midpoints. Now, they may be given directly or indirectly. Directly means the question will say D and E are the midpoints. But indirectly, which is most of the times, what words they can use? They can use the word bisector. They can use the word median. They can use the clear cut word midpoint. They can use the word half. So all these points, all these words indicate midpoint only. So you have to know that when you're looking at a question and you come across words like these bisectors or medians or whatever, they all mean that there is some information related to midpoint given. Some of you might not know what a median is, so let me explain that. Sorry. So you have triangle ABC, and if I drop a line on BC from A, let's just say D, then AD, if it is bisecting BC, then the line AD will be known as median. Please remember, AD is not perpendicular. I'm not saying that's not a thing. It is a thing, but a lot of times my own students, they come up with that confusion where they see a line drawn like this and they assume that if it is a median, it is a perpendicular also. No, there is a separate category of line altogether, which is a perpendicular as well as a median. We call it perpendicular bisector. But median just bisects the side on which it falls. Please remember, bisector, you might already be familiar with it. Bisector means if you draw a line and then bisect it, that means you're dividing it into two equal halves. That means this has to act as the midpoint. So, all in all, two midpoints will be given. They can use direct or indirect words. It's up to them. You have to be smart enough to pick up those words. Now, the next point, they will tell you that AB, AC, and BC are the three sides. So D and E will be the midpoints, but you will also have to spot that D and E are the midpoints of a triangle's side, not a quadrilateral. Please remember, you have a diagram like this, and I draw a line and I draw these two as midpoints, and I come up and a lot of times my students come up and say, so this is midpoint theorem. It's not. Please remember, it has to be a triangle's midpoint. Please remember that. Okay, the questions are made in such a way that they will confuse you. They'll tell you that this is a quadrilateral, these two are midpoints. No, those midpoints don't matter to us. Midpoint means the midpoints from a triangle, on the sides of a triangle. So what would you do if you come across a quadrilateral which has midpoints given? You would construct, you would try and create a triangle, not one but two triangle if you can. I mean, if that's what the question is expecting. But remember, the midpoints on a quadrilateral side will not give you midpoint theorem. It has to be on a triangle side. All right. So these two must be given for the midpoint theorem to work. Now, the main thing, the desert. What is the theorem? So the theorem says that if D and E are midpoints, then DE will be parallel to BC and DE will be equals to half of BC. What does DE equals to half of BC mean? That if BC is equals to 10 centimeter, DE will be 5 centimeter. Plain and simple. Do not overcomplicate it in your mind, please. Okay. So let's move on to the more important topic. You might be surprised at that. You know, midpoint theorem is a chapter where more questions are on converse of midpoint theorem compared to the midpoint theorem itself. You'd be surprised. Trust me on that. You will open the exercise of your textbook. You'll understand what I'm telling. So this is how you comprehend midpoint theorem. What is given? Two midpoints. It has to be given. If one midpoint is given, it's not a midpoint theorem question. If midpoints are given on a quadrilateral, it's not a midpoint theorem question. You have to make it one. You have to do some construction. You have to bring triangle in a game, and then hope and pray to God that it becomes a midpoint theorem question. So be smart about it. Know what you're getting into. All right. Okay. Now we are going to talk about the not given part. Okay, so in midpoint theorem, a lot of times you see half of the information and you jump the gun. You try and think that, okay, now midpoint theorem I can use. So remember, I have told you what are given points, correct? I've told you what should be given for it to work. I am going to tell you what should not be comprehended as a midpoint theorem question. So if the question says that I have one midpoint, it's not a midpoint theorem question. Okay, please understand, one midpoint does not guarantee the use of midpoint theorem. You need to have two midpoints. One midpoint, no. Okay, you also have to understand that a quadrilateral, which I had told you already, does not guarantee a midpoint theorem question. You have to construct a triangle so that you can see midpoint theorem working to your advantage. So be careful with these points. Let's move on to the converse of midpoint theorem. Now this is where things get interesting. It becomes much more valuable. Converse of midpoint theorem is a much more important topic. More questions on this. Okay. Now in converse of midpoint theorem, what is not given in the midpoint theorem will come as a given prospect in the converse. Let's try and understand. This is more interesting. So we have a triangle ABC. I have D and E. But in this theorem, converse of midpoint theorem, very important to understand what is given. How would you read a question and understand, no, this is not a midpoint theorem question, it's actually a converse of midpoint theorem question. How would you know that? Let's see. So, converse of midpoint theorem, only one midpoint should be given. Please remember, only one midpoint. So generally in this case, D or E, I mean, doesn't matter really, but one midpoint should be given. So E will be a point, but it won't be a midpoint. Okay. So in the converse, what you have to spot, if the question is giving me only one midpoint or it is giving me two midpoints. Two midpoints means midpoint theorem. One midpoint, then converse is also in contention. That's also a part of the game now. Second point, the DE has to be parallel to BC. So this will be a given information now. If you remember the midpoint theorem, this was a result. DE is equals to BC was a result. In the converse of midpoint theorem, D is equals to BC is given. Sorry, D is parallel to BC is given. That means one midpoint and the parallel line. As a result, what happens? So what is the converse of midpoint theorem? As a result, E becomes the midpoint. And when E becomes midpoint, then a whole lot of midpoint theorem comes into the play. When your D was already given as midpoint, E became a midpoint as a result of converse. That means both D and E are midpoints now. And that means you can easily say that DE will also be equals to half of BC, which is something similar as the result of midpoint theorem. So converse of midpoint theorem has, it's not your typical converse of any theorem, where the given and the proof interchanges or reverses. So this one, what you do is midpoint theorem, the given information will be two midpoints and triangle midpoints. They have to be midpoints of a triangle. Theorem is D becomes parallel to BC. So D is becoming parallel to BC. In converse of midpoint theorem, DE is parallel to BC was given information. That's the difference. So I hope you've understood what this whole charade around the midpoint theorem and converse of midpoint theorem is. I hope you understand how you read a question and decode that if the question belongs to the midpoint theorem or the converse of midpoint theorem. To summarize it all, I would, in the end, I would just explain you a very simple one-two liner what you have to do is you read the question. Look if in any way the question is indicating that you are dealing with two midpoints. The moment it says or mentions two midpoints, you're talking about midpoint theorem. But if anyway the question is suggesting that there is already a parallel line given and one midpoint given, that means you're looking at converse of midpoint theorem. A simple example. Now, this is actually a question too. So the question would say AD is a median. So what does it tell you? That BD and DC are equal. AD is a median means D has to be a midpoint. What does it bring to the equation? How we go and break this question? Look, the first thing you have to spot is the triangle itself. Look at the triangle. Sorry. If you see that a midpoint is given and I'm getting that shape of the triangle, that shape where the line is parallel or at least a point is given, a midpoint is given. So if I had to spot that shape in the question given to me, I'll tell you which two triangles I am looking at. If you notice, triangle ADF, it's called as point P. If you notice triangle ADF, it has PF, PE parallel to DF. So ADF represents the shape in which a midpoint is there and a parallel line is there. P is the midpoint. It's given in the question. Now, another triangle, triangle CBE. So CBE, if you notice, DF is parallel to BE and also D is the midpoint. But if you notice here in this example, if I consider triangle ADF, I have one midpoint at P. If I consider triangle CBE, I have one midpoint at D. I don't have two midpoints. I have only one midpoint. Yes, I have parallel lines, but midpoint, I only have one. So if I talk about triangle ADF and you're thinking D was also midpoint, D was a midpoint, but not of any side in the triangle ADF. D was a midpoint in triangle CBE. Remember what I told you in the midpoint theorem? It has to indicate a midpoint of a triangle's side. You know, it has to be midpoint of a triangle. Now, if you see, if you consider D, D is not a part of any side in triangle ADF. I mean, AD is a side, D is a part of it, but it is not a midpoint. But if you look at triangle CBE, D is a midpoint of one of the sides, CB. So in both the cases, in both these triangles, what you will apply is the converse. You can't apply the midpoint theorem. The simple reason is that I have one midpoint and a parallel side. I don't have two midpoints in both the triangles that I spotted. So here's a chain of events, how you will read a question and how you'll go. First, spot the triangle. Second, spot the number of midpoints. Is it one or two? If it is two, then you are talking about midpoint theorem. If it is one and a parallel line, you're talking about converse of midpoint theorem. So I hope I have explained you midpoint and converse in a simpler manner. That was the goal in the beginning of the topic, to be very honest. I don't want to really send you in a question frenzy before you understand the concept, okay? So please go through these slides as much as you want. I hope midpoint theorem and its converse is clear. In the next lecture, we are going to cover the intercept theorem. Till then, have a good day. See you later. Bye-bye.